2.1. We're going to learn today how to solve equations. When we solve these equations, what we want to do is we want to get the variable by itself. On the left-hand side, numbers are on the right-hand side. So we're going to start off with a very, very simple equation. We're going to solve this equation. So this is what we want to solve. And you've probably solved these type of equations before, but what we want to do, again, is get our variable by itself. And we want that variable on the left, numbers on the right. So how do we do that? Well, that x is already on the left. So let's move that 5 over. And whenever they cross the equal sign, we use the opposite. So it's right now a positive 5. So we'll move it over with a negative 5. And then we just add them together here. On the left-hand side, the 5's cancel. On the right-hand side, we have 9 minus 5, which makes it a 4. Later on, we'll learn that this is called a conditional equation. But that's a later part of this chapter. Okay. So let's just try to solve some more of these. That was a very basic one. I want to start off with a very, very simple one. And these can be done with fractions. These can be done with decimals. Let's do some with fractions because we always struggle with fractions. And I'm going to pick these from our textbook. So let's do 2 of these with fractions. These are on page 110. And let's look at question 24. If you don't have your textbook, not a problem, because I'll write them on the screen here. So let's look at question 24. We've got x plus 2/3 equals a minus 1/6. This is the exact same type of problem that we just did a minute ago. On the previous one, we had whole numbers, which whole numbers we generally don't have trouble with. We wanted to move that 5 over. It was a positive 5, so we used the opposite, which was a negative 5. And we just put those together. Now the same process is going to be done here. So we're going to go ahead and get rid of that 2/3. And so it's positive. So we're going to have to subtract off 2/3 from each side. Now, because of the fractions, we're going to work them out over to the side here. So we've got a minus 1/6 and a minus 2/3. So that's what we're working with here. When we add or subtract fractions, what do we have to have? Common denominators, right? So that means this 2/3, we need to make sure we have a least common denominator of a 6, because 6 and 3, my least common denominator is a 6. So I'm going to go ahead and multiply that negative 2/3. Well, I'm going to multiply it by 2/2. And then that's going to give me minus 1/6 minus 4/6, which is then a minus 5/6. So my answer then would be a minus 5/6 for the value of x. In later sections, we'll learn how to clear these fractions out. But in this section, we're just going to go ahead and work with them. Let's try another one. Question 26. Very similar again. This one just has a different sign and different fractions. But question 26, we've got p minus 5/9 equals a minus 1/2. So same procedure. Now we do work in terms of opposites. So this one is a 5/9 and it's negative. So the opposite of that 5/9 negative would be a positive 5/9. So we're going to add 5/9 to each side. On the left-hand side, those cancel. Those are inverses of each other, and they cancel out. So the left-hand side is just going to be a p. On the right-hand side, we're going to have to see what we've got. So we've got a -1/2 plus 5/9. And we're going to have common denominators. And the least common denominator of 2 and 9 would be what? Can someone tell me? 18. And how did we get that? Well, 9 doesn't go into 2, but 9 times 2 is 18, and it goes into 2 and 9 itself. So now we need our common denominators of 18. So we need to take that -1/2, and we're going to multiply that by 9/9 to make an 18 below. And the 5/9 will use a 2/2. Now we've got a -9/18 plus 10/18. Those have the same denominator of an 18. -9 plus 10 makes it a positive 1/18. So that's how we work out that. We just work the fractions over to the side. Because we don't generally have problems with whole numbers, where we run into issues is with the fractions. So we need to make sure we understand how to deal with these fractions. Write them over to the side and work them out. Again, in later sections, we're going to learn how to clear out our fractions. But in this section, we're just going to go ahead and work with them. Now we're going to look at one where we've got to move everything around to different sides and combine some like terms. So let's look at one of these. We've got to move variables and numbers all around. Okay. How about question 44? So let's look now at question 44. And that is 8t plus 5 equals 7t. And so our goal again is to get the t by itself. And there's different ways of doing this one, but we do need to make sure that the t is by itself on one of the sides. Doesn't matter really which one. Normally I try to get it on the left, but sometimes it might be easier to put it on the right. I'm just going to go ahead and move it to the left, so I'm going to move this 7t over. And what's going to happen when I move that 7t over? Well, now we have 8t minus 7t. So 8 minus 7, that makes it a positive 1t. And then we've got our plus 5. Now what happened on the right here? These are inverses, 7t and a negative 7t. That cancels, and that leaves you then with a 0 on the right, doesn't it? And you could have moved the 8t over and done it the same way. You would end up with the same answer. Now we have one more step, and what do we need to do? That 5t over with subtraction. And so that now leaves us with our final answer of t equaling a negative 5. And I generally like to make sure that our variable is going to be on the left. That's just the way that I do them. 48, let's try it next. It has a fraction, but it's not going to be very difficult at all to work with. We'll use the same process for this. So question 48, we've got 1/5 x plus 7 equals minus 4/5 x. Okay, so we're going to do the exact same way we did the previous one. So I'm going to move that variable over to the left and move the number over. Don't worry so much about the fractions because they're not going to be difficult to work with at all. So let's go ahead and add that 4/5 x to each side. And if you need to, you can write the fractions over here, and you can combine them together. They both have x's, so they can go together. Now, 1/5 x plus 4/5 x, well, that makes it 5/5 x, which is then 1x. So is everyone okay with how we went and combined these together? That makes it 5/5, which is then 1. We don't have to put the 1 in front of the x. Right? You can if you want to, but it's not required. You normally don't put the 1 there, but again, if you want to, you can. What about the right-hand side? Well, we still have that plus 7 on the left. On the right-hand side, those are opposites, so they go to 0. Now we're doing it the exact same way we did the previous one, just this has fractions. You haven't had whole numbers. So what do we need to do with that 7? It's a positive 7, so we'll move it over with a negative. That then leaves me with x equaling now a negative 7. So we work with the fractions over to the side. I'm trying to do one with whole numbers first and then one with fractions, so you see how the fractions work. Decimals work the same way. We'll do one of these that has a decimal also, just to make sure we understand how these decimals work, but decimals are no different. So let's look at question 52. For decimals, you can either use your calculator or just mentally combine them together. But for 52, we've got a decimal here. And we've got 1.9t minus 6 equals 0.9t. Exactly the same way we did all the others. Move that 0.9t over with subtraction because it's positive. And 1.9 minus 0.9, well, that leaves you with the 1. And we don't put the 1 there, so we just bring the t down. On the right-hand side, what does that make that now? 0 again. You could put the 1t there if you wanted to, but you don't have to. And if you struggle with decimals, just use your calculator. Okay? So if you want to, you can just use a calculator. And I've got mine around here somewhere. But yeah, I'll put it up on the screen so you can see what it looks like. Use a calculator. Here it is. So if you use a calculator, just use your calculator. No problem at all. If I want to use my calculator here, you've got 1.9 minus 1. Or sorry, 1.9 minus 0.9, right? That makes it the 1 there. So that's all you have to do is use a calculator, or you can do it mentally. And how do we finish this out? We need to move the 6 over. It's a negative 6, so we move it over. We use the opposite, which is a positive. And that gives me my final answer of x equaling now what? X equaling now 6. So is everyone okay with how these work? Decimals, you can use your calculator. Fractions, write them over to the side. Whole numbers, you can use a calculator or just mentally work them out. If you struggle with mental arithmetic, use a calculator. You make mistakes a lot when you add or subtract or multiply, divide numbers, use a calculator. I'd rather you use a calculator than make mistakes. So don't feel at all like you can't pick up the calculator if you struggle at all or doubt yourself. Let's try one now where we've got to move multiple things around and combine terms to make it work. So let's look now at question 67. I don't make you check the solutions. So you're not going to have to check the answers on these. Just work them out. We just want to solve these out. This one's going to require us to do some work here. We're going to have to combine our terms together first and then move things around. So we've got 3x plus 6 minus 10 equals 2x minus 2. So when we look at this question and one like this question, before we start moving things across the equal bar, we want to see if we can combine them together first. So always look first on each side to see if terms can go together. These are like terms here, that's 6 and that minus 10. So we're going to go ahead and combine them together. So now we've got a 3x, and 6 minus 10 makes it a minus 4. So now we're at this step. Okay, what do we need to do next? Well, our goal has always been to get the variable on the left. So we're going to move that 2x over with subtraction. 3 minus 2 is a 1. We don't have to write the 1, so we just bring down the x. And that's x minus 4 equals now negative 2. And we need to add that 4 over to get rid of it. Always use opposites. And that now leaves you with, watch your signs here, minus 2 plus 4. That leaves you with a positive 2. So your answer on that one would be a positive 2. Let's look at one that has more in it. How about 74? And then we'll look at fractions again. So question 74. We've got 7p plus 4p plus 13 minus 7 equals 7p plus 6 plus 3p. Before we move things across the equal sign, or the equal bar, we need to combine like terms together. So these are like terms here. So the 7p and the 4p, well, 7 plus 4, that makes it 11p. Okay, so there's that. Then we do the same thing with that 13 minus 7. A 13 minus 7, that gives you a positive 6. On the right-hand side, what do we have? We've got a 7p and a 3p. 7 plus 3 makes it now a 10p. And then we've got a positive 6. So we just combined all of our like terms together. As long as they have the same variable, they can go together. Now we need to finish it. So we'll move that 10p over with subtraction. And 11 minus 10, that leaves you with a 1p. And then that's a plus 6 equals a 6 there. We don't need that extra plus sign. We don't need that. And now what are we going to do? Move that 6 over with subtraction. A lot of times students make mistakes on this one because it's easy to mentally just add the 6 and come up with 12. It's not, though, because that's a positive 6, so we have to use a negative. And 6 minus 6 makes it then a what? 0. A lot of times those students will get to that step and they'll just mentally write down the number 12. So always take your time, write out the steps, that way you don't make a mistake. But numerous times I've seen students come up with 12 there instead of 0. Let's try one with fractions. So this one we're going to have to work with these fractions. Question 78. And 78, we've got 6/7 s minus 3/4 equals 4/5 minus 1/7 s plus 1/6. Okay, so let's go ahead and combine our fractions together as needed. Now the left-hand side, it's already done. These can't go together because that has an s, and this one does not. So the left-hand side is done. However, on the right-hand side, we've got our two fractions here. And those are going to have to be combined. So we're going to have to combine those together. So these are going to have to be combined together. So I'm going to split my paper here. And I'm going to work with a 4/5 plus 1/6. And what's the least common denominator of 5 and 6? Can someone tell me? 30, right? Because 30 will go into 5, and 30 will go into 6. We need our common denominators, so we need a 6/6 here, and we need a 5/5 here. So 6 times 4, that makes it a 24/30. 5 times 1, that makes it a 5/30. Adding those together, we have now a 29/30. So that's what we've got there. Now the s's are going to be really nice to work with because they're going to go together and we're not going to have to get a common denominator because they already have one. So we need to move that minus 1/7 s over. So I'm going to go ahead and add 1/7 s. Now you can either write it out or you can just look at it and see that 6/7 and 1/7, well, that makes it 7/7, which is then what? 1. So they go together and make it just a single s. And you can write it out with the fractions if you want to, but as long as you can see they go together and make the same denominator, then you can just skip that step. So then we have s, and we have a minus 3/4, and that's going to equal a 29/30. One more step, and that's going to make us add these fractions together. So we're going to have to add 3/4 to each side. And that gives us now 29/30 plus 3/4. So let's see what our common denominator would be. Well, what do we do to begin with? What's our larger number? 30. Does 30 evenly go into 4? No. But what about 30 times 2? Well, 30 times 2 would be what? 60, right? And 60, can we divide that evenly into 4? Yes. So what's our least common denominator? 30 and 4. That would be what? That would be 60, wouldn't it? Does everyone see how I did that? I just took my 30, didn't work, doubled it, which was 60, and that worked for us. So now let's go ahead and multiply that 29/30 by a 2/2. And 60 divided by 4 is 15. So we need a 15/15 here. Now we need 29 times 2. I believe that's a 58. I'll just double check myself. Yep, it's going to be 58/60. And then we've got 3 times 15. That should be a 45/60. They have the same denominators, so they can be added together. We've got 58 plus our 45. That gives us now 103/60. over 60. So my final answer then is going to be S equals now 103 over 60. And I don't think that's going to reduce down any. And that's as far as you can go. Fractions are a little bit difficult. Now, next week, well, not next week, but after we take our test in a couple of weeks, we're going to learn how to clear the fractions. So you won't have to deal with them much after this section. But it's good that we work with fractions. We have to get used to them. The more of these we do with fractions, the easier they eventually become. No different than whole numbers, they just require an extra step. Let's now look at question. Let's pick one of these to make us work it out. How about question 86? This one's going to make us use our distributive property and combine like terms together. So question 86. So we've got 4 times k plus 6 minus parentheses. Let's see, make sure I wrote it down right. Minus parentheses 8 plus 3k equals a negative 5. Well, what do we need to do here? First thing, before we do anything else, we need to make sure that our parentheses are done first. Now, nothing can go together inside because a k and a 6 can't be combined. 8 and a positive 3k can't go together either because that's got a k, that one does not. So what we now need to do is use our distributive property. So we're going to go ahead now and distribute that 4 through. And we stop at the parentheses. When they close, we stop. And then the next piece, we've got a negative. So I like to circle our negatives and distribute it through with our arrows. Just take your time when you work these out. So draw the arrows. I know it takes a little bit of time, but you're less likely to make a mistake if you draw the arrows and take your time. So now we have 4 times k, that's 4k. 4 times 6, that's 24. Now, the negative is going to switch our signs, so that's going to make it a negative 8 and a minus 3k. And the right-hand side stays the same at that negative 5. So we just used our arrows, distributed through, and that got us to this point. Now, what do we need to do from here? Before we move things across the equal bar, we need to make sure the left side and the right side are cleaned up. So let's go ahead and try to clean this up a bit. So we've got a 4k and a minus 3k. Those are going to go together and make it a k. Then we've got an 24 and a negative 8. So 24 minus 8. Well, 24 is the bigger number. It's positive. 8's negative, so we subtract them. 24 minus 8 makes it a 16. So that's going to be k plus 16 on the left. On the right, we still have that minus 5. What do we do to finish this up? We need to get that k by itself on the left. So that 16 needs to join the 5 on the other side. So we're now going to move that 16 over with subtraction. And that now leaves me with k equals, we've got minus 16, minus 5, watch your signs, both negative, my sign's going to be negative, and 16 plus 5 makes it a 21. So that should give you then an answer of k equaling now a negative 21. We'll do one more of these, and then we'll take a short break. Then we'll come back, and we'll look at 2, 2. Let's try one that's got more steps in it, 94, just to make sure we know how to work with one of these. It has lots of parentheses and lots of steps. we have 9 times 2m minus 3 minus 4 times 5 plus 3m. And we've got a minus 5 times 4 plus m equals a negative 3. Okay, so what are we going to do first? Well, we're going to begin by distributing through. And whenever we have a negative, I always like to circle it. So we understand that's a negative 4 that goes through. And the next one's a negative 5 that goes through. Let me take a moment to make sure I copied it down correctly. Everything looks right there. It's just easy to make a mistake. Okay, so we've got our arrows drawn. Now we begin multiplying. So 9 times 2 is 18m. 9 times a negative 3, that's a minus 27. Take your time and be careful with the signs. Negative 4 times a positive 5, that's a minus 20. Minus 4 times times positive 3, that makes it a minus 12, m there. Minus 5 times 4, that's a minus 20. And minus 5 times m, that's a minus 5m. And that equals now negative 3. So now we need to combine like terms together. You can use a calculator. You can do it mentally. It doesn't matter. So let's see what we've got for our m's here. We've got 18. We've got a minus 12 and a minus 5. So we can just use our calculator quickly to put these together. So let's make sure we can see that here. Yep. All right. I know it's a little dark there, but we'll just hope to be able to see it. So we just go ahead and put these together. So we have 18 minus 12, okay, minus 5. Putting them all together, what do we get? We get 1. So that's a 1m there. What about the numbers? What do we have for the numbers? Well, we've got 27, 20, and 20. What do we know about our signs? They're all negative, so my sign's going to be negative. You can put them in the calculator with negatives, or you can just make them positive, add them together, and keep your negative sign. That's what I'm going to do. So we've got 27 plus 20 plus 20. That makes it a 67. We know they're all negative, so that's going to be a negative 67. I think you're better off just determining the sign first instead of putting all the negatives in your calculator. You're less likely to make a mistake if you don't put the negatives in the calculator. So I just put them together. You can do it mentally too, doesn't matter. Now we need to finish it, so we have one more step. So what do we need to do? 67 needs to go to the other side. It's currently negative, so we move it over with a positive. We then put those together, and that leaves you with an m. And we have 67 minus 3. That makes it a 64. So in this case, my answer would be m equals now 64. Let's go ahead now and take a short break again. And let's meet back here at about 10:20. So we'll meet back here at 10:20, and we'll cover one more section. And then that'll be it for today.